we are finishing with our notes from yesterday. Okay, so we're talking about law of signs still today, but we're talking about the ambiguous law of signs. What does ambiguous mean? Who are my readers, my vocab people?
Huge.
Unclear. Unclear. Okay, nice. Can be interpreted in different ways. So we're going to be looking at the law of signs that can maybe be interpreted in different ways today. All right, so think back to geometry when you were proving triangles congruent. Remember all those lovely proofs and things that you did? Not my favorite part of math, but necessary evil. Miss Hightower would kill me for saying that. What were those 4 ways that we could prove triangles congruent? Do you remember? There were a combination of 2 and 3 letters. Angle, side, angle is one. Now, if it's angle, side, angle, don't we really know the third angle also? Like if I tell you 2 angles in a triangle, aren't I really telling you all 3? Because like you're locked into that third angle. So I'm going to put that other A. And it could be AAS. Could be angle, angle, side. Because I'm still giving you all 3 angles and a side. Yes, so we were trying to think of those other 3 ways to prove triangles congruent. Any more thoughts on that? Where I threw my pen, there it is.
Side angle, side.
Side angle, side, nice one. Another one? Side, 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 excellent. And the last one was kind of the weird one. It only has 2 letters. Hypotenuse leg. All right, so those are the 3 ways that you can prove triangles congruent. So what does that mean? Like, let's say that we did the side, side, side. What if I told you, okay, everyone grab a straw, cut lengths of 3, 4, and 7. Oh, let's do 3, 4, and 4. Okay, so you cut 3, cut 4, and make a triangle. Every single one of us would have an identical triangle. If all 3 sides were the same, we could only make one triangle. That's what that's referring to. Now, do you remember the one, who'd you have for geometry?
Scott.
Okay, Miss Scott or Miss Hightower, that you could not use side, side, angle. Do you remember that? We cannot use side, side, angle, or if we want to be a rebel, we can call it angle, side, side. Yes? Okay, so why can that not prove triangle congruence? Because, think about this picture down here. All right, let's say that I told you this has to be length 5, this has to be length 7, and this angle has to be 40 degrees. Other than that, you can do anything with the triangle you want. So this length of 5 and 40 degrees is locked in. And then I have this length of 7. Think of it like it's on a hinge here. So I could potentially swing it over this way so that this is still 7, but I create a whole nother triangle. Because remember, this side was not locked in. So I could extend that side, make it longer to reach this side of 7 when it swings out this way. Can you picture what I'm talking about? So you've got 5 locked in, can't move. 40 degrees is locked in. So this side can't move, but it can be extended. Well, this side of 7, I can swing it back and forth and not change the length of it. So it's possible that it could swing over here. I could extend this and make an acute triangle out of all that. Whereas up here, this one is obtuse. But I still kept those 2 lengths and that angle of 40. So that's what side-side angle or angle side-side is referring to. And that's why we can't use it to prove triangles congruent, because sometimes we can have more than one triangle out of that information. Okay, so yesterday when we used law of signs, we were given 2 angles and a side. On every single problem, we were given 2 angles, which really meant we knew all 3 angles, right? We just had to subtract the 2 we were given from 180, and that found the third angle for us. So we knew the angles and a side. Well, today we're going to deal with side-side angle, or angle side-side. And when that happens, there are actually three outcomes that we'll find. One is that there's not even a triangle possible. Two, there's one triangle. And then also, sometimes we're going to encounter two possible triangles. Okay? That is only when you have angle side-side. So that is a red flag we have to be aware of when we're given that information, that this is kind of the weird one. It's the ambiguous situation. It's not just one triangle. What do I mean by no possible triangle? If I gave you any lengths, couldn't you make a triangle? No, not necessarily. To me, I think of it as like a staple. What if this is length 10, and I said take 2 and 1 and make a triangle? They won't reach, will they? So, do you see what I mean? It looks like a staple. Staple that hadn't been closed yet. So, what is the rule? What has to be true about the sides to even form a triangle? Okay, so if they have to equal it, then I could have 5 and 5. Yes. So okay. So I heard Pythagorean theorem. That's only if it's a right triangle. Not every triangle is right. But think about if these two add up to 10, then they would just meet when they fold in. But what about when they rise up? They're not going to meet anymore, are they? Okay, so the rule is that the sum of these have to be greater than the other. So I could have a length of 10. I could have a length of 6 and a length of 5 so that they overlap just a touch. And then when they raise up, then they'll still meet and form a triangle. Does that make sense? Okay, so the sum of any two have to be greater than the third for the triangle to even be possible. All right, got off track a little bit there. Okay, get your calculator, and I want you to find the sine of 40 degrees. Make sure you're in degree mode first. Sine of 40. Okay, so I have 0.64278761. Now find the sine of 140. What do you notice? I got the same exact answer. Okay, and hopefully that's not a totally big surprise to you, because if you think on our unit circle, let me go get a unit circle super quick here. We can find a unit circle. That's not one. Oh my goodness. Here we go. Alright, so if we look on a unit circle, look at the sine of 30 versus the sine of 150. Aren't they the same? Okay, this is 30 and this is 30. Okay, if I go to 45 and 135, the sine values are the same. This is 45, this is 45. Sine values are the same right there. So if I go to 40 degrees, then I have some point on the unit circle, and guess what the y value is? Right there. We found it, that decimal. But if this is 40 degrees, and this is 180 minus 40, which is 140, then it has the same exact y value across this circle. So it makes sense that the sine at 40 and the sine at 140 are the same. Okay, now, do you remember when we do sine inverse on our calculator, it will only check those two quadrants, right? Okay, so if I took my calculator and I did sine inverse of that decimal, so I'm going to do sine inverse of that number, then I get pretty much 40 degrees. It's got a 2 out there because this decimal was rounded. So 40 degrees though. Okay, well, that's because it's only checking the first quadrant. We know that there's another angle over here in the second quadrant that could have that same sign. We just saw that. It's 140 degrees. Could 140 degrees fit in a triangle? Yeah, if the other two angles were small. So maybe I don't need 40 degrees. Maybe I need 140 degrees. That's where the ambiguous and the two possible triangles will come into play. Because I'm going to ask the calculator, hey, what angle has this sign? And it's always going to give me something in this quadrant. But I have to check and see if maybe something in the second quadrant would work also. Okay? So that's where the ambiguous stuff comes from. Okay, so we're going to be on alert whenever we see side-side angle. We're going to draw a picture, and then in the end, we're going to compare those ratios like we talked about yesterday. Is the shortest side opposite the smallest angle? Is the longest side opposite the biggest angle? Etc. All right, so let's jump in with 3 examples. All right, solve the triangle B equals 118. Little b is 8, little c is 10. So the first step is always going to be draw a picture. If I know that something's obtuse, I can go ahead and draw it obtuse. But if you just draw some generic triangle, then that's cool too. Label that, and that, and that. So what's missing is angle A, angle C, and little a. So those would be the 3 things I need to find. Okay, so can I use opposite adjacent hypotenuse? No, it's not a right triangle. So out goes sine, cosine, tangent ratios. So then I rely on what did we talk about yesterday? Law of sines. So I'm going to say 8 over sine 118 equals 10 over sine of C. I don't have any part of the A fraction, so I can't use it. I don't know the angle or the side of A. We're going to cross multiply. 8 sine C equals 10 sine 118. How is this different already from yesterday? The unknown is the angle. Yesterday we never had that happen. We knew the angles every time. We were always solving for a side. Okay, so that's a sign that, oh, this might be a weird kind of problem here. And is this an angle side angle? Yes. Here's the angle you were given. You knew the next side and the next side. So angle, side, side. So be on alert. Okay, I want to solve for sine C because I can't separate sine and C. Sine has to have an angle that follows it. So we're going to divide by 8. And 10 sine 118 over 8. Okay, how do I find the angle again when I'm looking for an angle? What do I do on the calculator? Inverse, yes. So I have to say, hey, there's an angle whose sine is this number. So that's what the inverse does for us. So I'm going to say second sine. And I'll just go ahead and put that fraction in now. 10 sine 118 over 8. And let me write down what I did here. I'm going to put that whole fraction there. And I get domain error. Okay, let's see what this fraction equals. If I just evaluate what's inside there, 10 sine 118 divided by 8, then that number is 1.1. Does any angle have a sine of 1.1? what does sine never go above? 1, and never goes below -1. Think of your sine curve. It never goes above 1, never dips below -1. So there's no angle that has a sine greater than 1. So this is not possible, does not exist. So what that tells me is that there is no triangle possible here. Okay, hang on one sec, I'll show you. I just found this fraction right here and replaced it with that decimal. Okay, so my answer is that I can't find you a triangle because it's not possible. Now, don't be mad at me, but we could have avoided all that work. And we could have known that from the get-go that there was no triangle possible. How? Yes, so always check those ratios. 10 is longer than 8, but there's no way there's an angle bigger than 118. So clearly the biggest angle is not opposite the biggest side. So if you encounter a situation like that and it just doesn't make sense, then you're done. There's no triangle possible that fits that description. Okay? We're good? Any questions on that one? Okay, so let's look at the next one. Solve the triangle if A is 4, B is 3, and angle A is 112. It's another obtuse. 112 is my large angle. A is 4, B is 3. Okay, so I'm not trying to trick you on this one, because that longer side is opposite the bigger angle so far. So we're good there. All right, so we're going to set up law of sines. I'm going to say 4 over sine 112 equals, what do I have to use? The C's or the B's? The B's, because I know side B. So I set up 3 over sine of B. Okay, so what's missing is angle B, angle C, and little c. Okay, we're going to cross multiply. 4 sine B equals 3 sine 112. Divide by what? Just 4. So sine B, we can go ahead and get that fraction if you want to, just to sort of catch anything that's above 1 or below -1. So I get 0.696. Now, when I do sine inverse, don't use the abbreviated approximated decimal. Go back up and grab the full decimal on your calculator. So sine inverse of that whole decimal gives me about 44 degrees. Are you okay with that angle? Because remember, that's what sine of the angle equals. So we have to have the calculator match it up with an angle for us. Any other questions on that? All right, so I know that angle B is 44. Okay, well that means I can find angle C pretty easily because they all have to add up to 180. So 180 minus 112 minus 44 leaves 24 degrees for this one. And that just leaves side C to find. Remember, I still don't have a right triangle, so I can't use opposite adjacent hypotenuse. I have to use law of sines again. Stick with the ratio that we started with because we didn't round that. If I use this 44, then I've rounded that answer. It's going to make my final answer be a little bit off. So I'm going to stick with the 4 in the sine 120. C over sine 24. And I'm going to cross multiply. What do I divide by? Sine 112. Am I using inverse on this one? No, I know the angles, so I'm just straight up typing that fraction in. That will give me C. Just like we did yesterday. And I get 1.7 for side C. Did it round? Yep, my bad. Rounds up to 1.8. Okay, so let's list 1.8. 1.8 here. Do a quick check. Is the shortest side opposite the smallest angle? Yes, so we're probably good. And that is our solution. All three of those values. Question? Okay, so we did one where we had no triangle. We did one where we had two triangles. Can you guess what happens next? I mean, we did one with none, one with one. Guess what's going to happen next? Two. Okay, let's see how on earth we would know that's going to happen. Draw a picture. Little a is 6, little b is 7, angle A is 30. So I am looking for angle B, angle C, and little c. All right, so we start out law of sines, normal, everyday, routine, 6 over sine 30 equals 7 over sine B. No big deal. We cross multiply, and I'm going to get 6 sine B equals 7 sine 30. Divide by what? Just the 6. I can't separate sine and B. Okay, how am I going to find B? Inverse. So sine inverse of that fraction there will tell me what angle B is. And I get about 36 degrees. Is everybody good with that? Okay, so this is where we decide if there are two. And I'll show you why I didn't do that on the previous one. Okay, so I take 36 degrees. So the calculator identified 36. 36, but then there's this corresponding angle over here that is 180 minus 36 that would have the same sine value. So what is 180 minus 36? 144. Is it possible to have a 144 degree angle in a triangle that already had 30 degrees? Are those possible to have in one triangle? Yes. I mean, the leftover little angle is going to be tiny, but it's possible. That tells me I will have two triangles. Okay? All right, so let me write this down. So we will have two triangles because 144, which was the supplement of 36, 180 minus 36, will fit in the triangle with a 30-degree angle. So if we have enough left over for a third angle, then that tells us that there will be 2. So jot that down and then really read it and see if you have a question on that. And that should be triangles.
Whenever you add 144, 36, and 30, you get
Not adding 36. So what I'm going to do is say, okay, maybe it's not 36 that I need. Maybe it's 144 instead.
and then that'd be split by 2.
And then I'll use the 144 with the 30 as opposed to 36 with the 30. And that creates the second setup. So these two added together is 174. But I have a little bit left over for that third angle. Okay? Yes, ma'am.
So why would example 2 be it?
Okay, so let's stop there and go back and see why I didn't do that here. Okay, so I got 44 degrees. What's the supplement of 144? It's 180 minus 44. 136. But remember, the angle we were given was already obtuse. I can't fit 112 and 136 in a triangle because that exceeds the 180 degrees. So if you're already given an obtuse, there's no way you're going to be able to fit another obtuse angle. So if the given angle is obtuse, it will either be no triangle or 1. Okay? All right, so let's go back and see where we are over here. So I know I'm going to have 2 different triangles. So I'm going to separate that off. And I'm going to go ahead and set up triangle number 2. Now what I can't change is what we were given.
So is B 36 or is it 144?
It'll be 36 up here and 144 down here. So I'll have both. Okay, so maintain all the information that we were given initially. Angle A is 30, side A is 6, side B is 7. I'm still missing angle B, angle C, and side C. But let's go back up here. In this scenario, angle B is 36. Okay, well if A is 30 and B is 36, then what is C? 180 minus 66, 114. And then I just have to use law of sines one more time to find side C. So again, I'm going to use that pair that I was given, the 6 over sine 30, because I didn't round anything there. And then I'll use the C over 114, sine of 114. Okay, we're going to cross multiply C sine 30 equals 6 sine 114. Divide by sine 30. And I'm not doing inverse here. I'm just typing in that fraction. When you're looking for the angle. And so I'd round that to 11. Okay, let's do a quick check. Is the biggest side opposite the biggest angle? Yes. The shortest side is opposite the smallest angle? Yes. So this right here is triangle number 1. Any question on triangle number 1? Okay, so now we're going to go down the second triangle. Remember, the same given information. I can't change that. But instead of angle B being 36, I'm going to use the supplement, which was 144. So I'm going to say, well, actually, B could also be 144. Okay, if that's true, then these add up to 174, leaving how much for angle 6? 6 little bitty degrees. But we had enough left over for a third angle. And then we'll use law of sines to find this C. Now this should be much smaller because it's opposite a 6-degree angle. So I'm going to say C over sine 6 equals 6 over sine 30. Cross multiply. Divide by what? Sine 30. Am I doing inverse on this one? No, I'm not looking for an angle. Just the side C. So type in that fraction. And I get about 1.3. 1.3. I'm going to label that and just do a quick check. Was the shortest side opposite the smallest angle? Yes. Longest side is opposite the biggest angle? Yes. So that represents triangle number 2. Question. All right, that was not too much fuss. We're good? Okay, I'm going to put the answers to your homework up here, and then I'll freeze the screen up here. And I'll come around with your homework. You have 5 problems. Oh, there we go. Okay, there are your answers.